Hi, my name is Chris Gurzen, and this is my presentation for the JSL final module, a KanBan app that we are to debug and connect the various pieces to. So just before we begin, I want to make sure that we are working with a clean state. So I'm just going to enter the browser console here, and I'm going to check that our local storage object is clean. And from what I can see, local storage length is 0, which means there's no entries to this object, which is a way to persistently save data for the browser. So I'll just go ahead and close the debugger, and we'll move into the project. So this is the startup screen that we are greeted with. There is some initial data that we have been provided with that is loaded in here. And we must be able to both add to this data, remove it, as well as modify it, and be able to move between different boards. So these are the boards to our left here on the sidebar, and these are the tasks that's present for each board. Every task has a status of 3 choices: to do, which means we haven't started it yet; doing, which means we are busy with it; and done, which means we have finished this task. And we are able to change this. For instance, let's say build portfolio project. We've done a couple of those, so we can say we've done this. So we can change our status to done, save that change, and it's finished. And just to make sure that if we change this and hit cancel, you see nothing happens. It stays where it's supposed to. I don't want to delete this quite yet, so let's maybe create a new task and see what we can do. So do JSL presentation, make a presentation for the KanBan app. Just fix my, there we go, and we'll say we're busy doing this. Create this task, and it appears under the correct board with a name, and we can open it back up again to change anything we'd like, and it'll move where it's supposed to. And if we want to remove it, we can just say delete task, and it's gone. And we can move between our boards to see the different tasks that is present for each board. And for instance, just to show that this is in fact persistent data, we can add a new task. Let's add something completely unrelated. Walk the dog. Take that beauty for a jog. We'll say we got to do that. So that's something completely unrelated. We'll just do a little refresh at the top here. Very quick refresh. But we can see that the data is persistent. It doesn't disappear between refreshes. And we can delete that task again, refresh, and it's gone. Same thing here. And the beautiful thing is our board state is also persistent. So when we refresh, we will always go back or get back to where we left off from. So our KanBan state is always saved in local storage. We have the ability to toggle between light and dark, and this is also a persistent state. If we refresh, we will get back to where we left off from, and we can also hide the sidebar if we want more space to work with, which is itself a persistent state. It doesn't move away. So these are the basic features of the KanBan app that we've been asked to debug and make sure it's properly implemented. Let's move to the code. So for the coding, we are relying on 2 modules. The one is initial data. So this is the data that's been loaded when we first opened up the app. This has been provided to us as a convenience for some data to work with. And then also, much more importantly, is our storage emulator. So these functions allow us to interact with local storage and save our data and update it and delete it as necessary. Over here we've got some 2 very important global variables. The first one, elements, is an object containing references to UI elements that is frequently used throughout the program. We just get a persistent reference to these, so we don't have to continually grab references in our functions, and so that we can also use them in different places. This variable, ActiveBoard, is a very important variable that is used throughout the program as well. And it's the only variable in this program that is constantly updated, which is why it's defined as a let and not as a constant. The active board variable is always set to the board, which would be this one to our left, that is currently active. And it uses this as a reference for everything else that's happening inside of the program. For the main functionality, and many of these functions was not written by myself, but was provided to me and just asked for a debug. So the first one we'll work with is fetch and display boards and tasks. What this one does is it gets the tasks that's been saved in local storage through this function that we've imported from up here. We then, this is a very complex little statement, there's a lot going on here. So the first thing we do is we take the tasks that we've been given, which would be an array of objects. We take those array of objects, we run the map function over them, and we extract from them the board property from each of those objects. Then inside of that, we filter them through the Boolean function to take away any null or undefined values if they are, so that we can only have properly set values available to us. And then once that's done, we wrap that inside of a set constructor so that we can get all of the unique values. We don't want replicates, so we just get the unique values, and then we unpack that back into an array. And then we pass that array of boards to the display function, which what that does is it just creates a UI element for each of the boards and adds them to the left side of the panel, and adds a click listener to each of these boards, which then listens for which one we want active. So whenever we click on one of these boards, what it will do is it will filter and display the task by board, which, as the function suggests, it then takes the main user interface and displays the tasks for that specific board and sets our active board to this board. Very important because we keep on using this variable. We style this so that we know which one is active, and it saves this to local storage as well, so that when we refresh, our state's persistent and it goes back to where we come from. Okay, then after it has displayed those boards, it then checks if there was any boards extracted from this, which when there is, it will try to find an active board. If there isn't an active board, it sets the first board that we've extracted as the active board. It sets the top name to that board, which is at the top of the main display. It gives you the name of the active board, even after you close the sidebar, which would normally show you which board is active. You can still see the heading of which board is active. Styles that board to give it the active glow, and then refreshes the tasks UI. And the refresh task UI is just simply a wrapper around the filter and display tasks by board over the active board. So again, this reads the active board variable and then displays the task for that specific board. So that is those functions walked through. Boom, 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 boom. Then, okay, filter and display tasks by board is also a pretty complicated function, but in essence what it does is it gets our tasks, it filters those tasks down by the active board name, which is usually where this is used, but whatever board name we pass it, so it gets the tasks for that specific board, and then it goes ahead, looks at the column divs, and then creates those tasks for each of the columns and adds them based on their task under the correct column. So this is what we're doing down here with the filter tasks. We look at where they're supposed to be and we add them over there. And on every task we add an event listener, which allows us to edit the said task. And the editing function, we'll get to that in a minute, allows us to change the status of the board or update its information. Boom, boom, boom. Okay, so that's that. Setup event list. Setup event listeners is just a wrapper function that we use in our init place to add some functionality across the app. So it does simple stuff like allowing us to toggle our edit task modal when we click our cancel button. So the false variable tells the toggle modal to close it. So if we go down here to the toggle functions, we've got the toggle sidebar. toggle theme, toggle modal, and open edit task modal. So toggle modal is quite simple. So first thing, it's got the show variable. It's a Boolean variable. Expect a Boolean variable, true or false. And for its default modal, it just opens up the create task modal. Um, on its function call, it will either show or hide our modal, and it will show or hide a filter div, which is just a background overlay to show that the rest of the app is not interactable with while our modal is open. So it by default works on the create new task modal, but we can also pass it in the edit task modal on which it will then operate, such as over here. So if this false means we want to close the edit task modal for the cancel edit button. And then the cancel add task button, same thing, except we don't have to specify this element because it's specified by default. For our filter div, what we want to do is whenever we click outside of the modal on top of the filter div, it's going to close our modals. And in here I've added both modals so that it doesn't matter which modal is active when we click on the filter div, which pops up whenever we open up the modals, it will dismiss them. And then for the side show bar, obviously, we've got the hide and the show. Again, these elements we've referenced up here already. And all we do for the hide, which would be the little red no sign when the sidebar is open, it will close it. And when the sidebar is open, or then it'll open up these little eyes on the side. If you click that, it'll open up the toggle bar again. Our theme switch, quite simple. So that's a little switch from light to dark. Whenever we register a change in state, it will run the toggle theme button. Create new task button. So yes, again, when we click on the create new task button, which is at the top right, it'll open up our create modal. So again, toggle modal, so it'll open the modal, and the default one being the create task. And then down here, so what we also want to do is whenever we submit this modal window for the create task, we want to run this function add task on top of the event, and we'll get to that one in a second. So I've already walked through the toggle modal, which just, as I said, either shows or hides whichever modal we pass it, and it'll also show or hide the filter display at the back. Toggle sidebar, so this one also does a couple of things. What it does, so true or false value. If it's true, we want to show the sidebar. We want to hide the little show button, which are the little eyes which pop out when we close it. And we also want to save its state so that's persistent and we know what's happening. And obviously for false, the reverse happens. We hide the sidebar, we show the little eyes that allows us to open it back up again, and we set the state to false. Toggle theme, so this listens for which theme we want. So what we want to do on this function, it doesn't receive any parameters, but instead what it does is it checks the state of the theme switch itself, which can either be true or false. We do it this way so that our toggle function is synced up with the state of the switch. We don't want to run into a situation where we toggle to light, then the UI switches to dark, or we toggle to dark and then the light UI switches to the opposite. So we check for that state, and then we do accordingly. So when it is true, it switches to light, which then adds that class list to the top level of the document, which is the HTML level. So when we go into our CSS over here, way at the top, we've got a root element, which would be the regularly defined variables that we then use for the dark theme. And the light theme also has these variables declared. So what happens when we toggle to this class on the root element, which is the HTML element, it swaps out these variable names or these variable values for these names. So we still use these variable names throughout the CSS document. So like over here, we've got the background. We reference the secondary color variable. And when we swap between these two different um, definitions, it just changes the reference over here between these two values. So that's how we're able to toggle between light theme and dark theme. And then we also change our logo from a light to a dark logo so that it stays consistent with our theme. Okay. The big one we got to talk about is the add task, which what that would do is when we've added in information to create a new task, it gets the values, it trims off any white space. We need to see if our task at least at minimal has a title. So we check if the title isn't empty. If it is, we give an alert to the user to warn them that they must please enter a proper title. We reset the value in case they maybe entered a bunch of empty spaces, and we return the function. So we don't do anything else. We just stop it right there and give control back to the user. But if they've passed these checks, then we create a new task, which we then assign the different properties to the properties that the user has entered. And again, very importantly, we reference the active board so that we add the task under the correct board. So the user would go to the specific board that they want to add the task to, and when they do that, we reference that board inside of this variable, this new task that we create, this new object. Then once that's done, we add that to local storage using the create new task function, which again, that we've imported from up here. And then it'll return the task as is. Then we take the modal away, we reset the form so that we don't have anything left, and we refresh the UI so that the new data is present on the UI immediately. So toggle theme, toggle sidebar we've covered. Then open the edit task modal. So this is very similar to add task, except we want to pull in existing data and allow the user to modify it. So again, what we do when a user clicks on the open edit task modal is we will, I think it was defined over here. Yes. So inside of this closure, we would have passed the task, the specific task that's linked to that UI element, to this function over here. So when they click on that UI element, it'll open up the correct task. And then from that task that we've then referenced over here, we can get its title, description, and status and put that as the values for the form element, which is then open to the user to then modify. We get some references to these elements, the save and delete button. The cancel button has already been given a event listener over in the setup event listeners to dismiss the modal and clear the filter, which is fine. So then when this modal opens, the information is displayed to the user and they can then modify it. And then they've got two options. They can either modify the information and save it so that it's persistent and any changes is reflected, or they will delete it and it's completely removed. The delete function is probably the easy one to look at. So what we do is we just take the ID of the task, we run the delete task function, which is what we've imported from the local storage function helpers. It'll remove that from local storage. It'll take away, and then we just take away the modal and we refresh the UI. So the refresh UI will again go and look inside of the local storage, and obviously when the task has been deleted, it won't show up on the UI. So the change is immediately apparent. The save button, that's a little bit more complicated, but what we do is the first thing we want to do is check if the form is valid. So making sure that not any invalid values have been given or that's been tampered with. The report validity function is very useful because it does two things. It checks whether the form is valid, returns a true or false value for the developer to use, but it also notifies the user whether a certain field has been properly used. And this is usually handled by HTML itself. So when we look at the HTML document and we look at the new task modal or the edit task modal, we require there to be at least a title, and we do this through the required keyword inside of the input object. So if there is no title and the user tries to submit the form, and we run the report validity, what it's going to do is it's going to return a false for us to saying it's not valid because the required input's not there, and it's going to tell the user as well. We can just quickly demonstrate this by going to our task. So if I do this and I try to create a task, it's going to tell me please fill out this field. It's the minimum necessary. And the same thing is if I try to edit a task and I delete the title, as I save changes, it's going to tell me please give me a valid input here. So that's the way that that is being checked out. And then again, once that's done, we get the values back, we check if everything is valid. So that it's done, but you can circumvent that by just adding a bunch of spaces, and we then manually check if the title isn't empty, just to make sure they didn't add a bunch of spaces. Then we save the changes using the put task method. So what that does is it just replaces the existing task at the task ID. So we create an entirely new object, but we can reference some of the old properties, such as the ID, which is the only one that we'll use, but we'll update the title, the description, and the status as the user wants it to. And again, we reference the active board. I suppose we could have just referenced it from the task ID, but I feel it's safer to reference it from the actual active board that's displaying on the UI, so that it is consistent with what the user sees. The put task function I've modified to just return me a value, whether that has succeeded or not, true or false. If it hasn't properly saved, we just console log that something's failed to update, and it will be apparent once you refresh that whatever changes you made hasn't been made. And then once that's done, we close the modal and we refresh the UI to update the changes. So that's the event listener that's added on that. And for these specifically, I've opted to use the on-click method of adding an event listener instead of the add event listener method. The reason being is that this function can run possibly multiple times on the same element. And if this is the add event listener method, what will happen is it'll register that function several times, and all of them will fire when you then try to do one of these actions, such as clicking on the save button, which can be problematic because sometimes those functions that's called in here are not idempotent, which means when they run multiple times, the state is going to change in unexpected ways. But using the on-click method of assigning a function, we can guarantee that there's only one function ever assigned to that button. So it doesn't matter if this function runs multiple times, it will only ever register this singular function, the latest one, on these buttons. So we can be sure that this function will only be called once we click that. So this is the main functionality of the app. Down here, this is how we initialize it. We've got two functions: initialize data, which is, again, if we don't have any data present, it's going to pull from the imported data and it's going to update local storage with that. If it's already present, then we just say it exists and we don't have to worry about it. And then the init function, which sets up the event listeners to give the app its functionality. We then get to see if the sidebar should be shown or not, and then we toggle this the sidebar accordingly to that value. And then for the light theme, we also check whether that should be enabled. And then what I do is I take the theme switch and I make its state to be the same as the state that is saved in local storage to make sure that it's consistent. It's a way to sync them together. And then we just run the toggle theme function to make sure that the theme that's being displayed, so the classes that are applied, is consistent with what the theme switch is saying and what has been saved in our local storage. And then we just run the main function, which is fetch and display boards and tasks, which will then look at all the boards and tasks in the local storage, process them, and then pick the one that should be active, whether we've set an active one or just take the first one as the default active one, and then display the app. And that's it. That is a very simple Kanban board app. There is some room for expansion here and some cool little functionalities. For example, if you want to drag and drop items between their statuses, that can be implemented with a little bit of work. Don't need any third-party libraries or something like that. HTML already provides this functionality this functionality natively. And obviously a cool function to add to this app would be to add and remove boards, which is the big one. But yes, so that's my presentation of the app and its code, and I hope you enjoyed it. See you next time. Thank you very much.